So the t-distribution basically is just a family of curves. And the family of curves is based on this concept called the degrees of freedom. So here I have 3 t curves up here. All right? And if I want to grab one of my members, one of my family members, I just have to pick a degree of freedom. I'll get into that more in just a moment. But once I have the degree of freedom, I have my t-distribution, and from that t-distribution, then I can do whatever it is I need to do. So I can get my t-scores, you can compute probabilities, you can do anything you want. But let's just make a couple of observations here. When the degree of freedom is 1, notice that this blue curve is shorter than the other 2 curves. Agreed? And also notice that the tails come down towards the x-axis slower, if you will, than these 2 guys over here. So the smaller the degree of freedom, then the shorter the curve and the thicker the tails. And as the degree of freedom increases, notice here up to 6, to the orange curve, notice that the distribution becomes taller and the tails are pulled in a little bit more. And if I go up to a t curve of about 25, it's going to be taller than the t curve for 6, and the tails are going to be coming down quicker towards the x-axis. So in other words, as the degrees of freedom increases, the curve's going to become tall and narrow. All right? And then finally, if you take a look at this green curve, the green curve here is the standard normal. So the idea is that as the degrees of freedom increase, the t-distribution is going to converge to a standard normal. Anybody care to take a guess at about what value of the degree of freedom where these 2 are pretty comparable? How much? A little bit more. A little bit more. A lot more. 30. 30. So it's kind of interesting that the t-distribution right around 30, I'm not saying at 31 it becomes exactly, but I'm saying that they become awfully darn close. Right? And if you take a look at the t-chart down towards the bottom, you'll see that there's not very much difference when the degree of freedom is 30. Here in just a few moments, when we take a look at 90, 95, and 99% confidence intervals, the t-scores, no matter what, the t-scores and the z-scores will be really close to one another. And if you'll also notice, the blue curve and the orange curve are centered where? At 0. So the mean of any t-distribution is always 0. Okay. Now the standard deviation can be different. All right. Clearly the standard deviation is not going to be the same as the standard deviation for the standard normal. Okay. So again, just some properties. One, as we can see, the t-distribution is bell-shaped. It's symmetric about its mean. The mean, median, and mode are all equal to 0 and at the center. And again, the tail end of those t-distribution curves, the tail end, are asymptotic to the x-axis. Again, all that means is that they will never touch or cross the x-axis. They just get closer and closer and closer. Kind of like you and your siblings. Don't touch me, but you guys used to get really close to one another. And then scream, Mom! Remember those days? So the t-distribution also differs a little bit from the standard normals, so the variance is bigger than 1 for the t-distribution. It's going to be larger. The t-distribution is actually the family of curves, as I stated, based on the degrees of freedom. And the degrees of freedom are related to the sample size. For confidence intervals, when you're using the t-distribution, the degrees of freedom is always equal to n minus 1. Okay, so for my visual people, df equals n minus 1. That's the relationship. And then Again, as we stated, as the sample size increases, the t-distribution approaches the standard normal distribution. All right, so the next thing I'd like to do is to pull out the standard normal tables, and let's take a look at those. So your tables should look fairly similar to mine. The idea is that we have our key right here, and notice that what the table is going to give back to us are these t-scores that we've been talking about. So we get the upper tailed area. We have the upper tailed area that's shaded. And then what these tables will give back to us is this t-score. All right? So if you take a look at the columns, t sub 0.1, t sub 0.05, t sub 0.25, t sub 0.1, t sub 0.005, this these subscripts down here relate and are this upper shaded area. So this is the area right here. Everybody with me? And then the rows are your degrees of freedom. So the idea now is I want to come up with the t-score where's it at? As I gingerly go through this thing. There it is. So now what I'd like to do is to compute this t-score when my sample size is 18 and my confidence level is 99%. So to find the t-score, why don't we just do the following? First, we know that alpha is equal to 1 minus the confidence level. So this is equal to 1 minus 0.99, which is equal to 0.01. Next, we could take alpha over 2, which is 0.01 divided by 2, which is equal to 0.005. So now we have our area. That's our area, our upper tailed area. The degrees of freedom is equal to 18 minus 1, which is equal to 17. So now that we have this information, all I have to do is come over here to the tail area, t sub 0.005, and then come down to 17 degrees of freedom. Well, here is 17 degrees of freedom, and then right here we have our t-score of 2.898. Okay? So if I want to find the t-score when n is equal to 15 and we have 98 degrees of freedom, or 98% confidence. So again, we'll do the same game. Alpha is equal to 1 minus 0.98. Alpha over 2 is equal, this is equal to 0.02, if my memory serves correct. Alpha over 2 is 0.02 divided by 2, which is equal to 0.01. Our degrees of freedom is equal to 15 minus 1, which is equal to 14. So now I have everything that I need, so we'll just come back over here. So t sub 0.01 is right here. Degrees of freedom we said was 14, so our t-score then is 2.624. Pretty much a piece of cake. What do you say? I hate to disappoint you, but I cannot make it any harder than that. So what I'd like for you all to do then is to take a few minutes, take about 2 minutes, and I would like for you to compute the t-scores for these two guys. All right, ladies and gentlemen, so for n equals 11 and 90% confidence, the t-score is going to be what? I'm hearing 1.812. Glad to know I got it right. And for the next one, 2.447. So I showed you how to do a couple, you did a couple, so you are now professionals at finding t-scores using the t-chart. All right?